Hi guys, in continuing on with our energy systems discussion, today we're going to talk about anaerobic glycolysis. We have previously spoken about the phosphocreatine system, and now we're moving on to anaerobic glycolysis. So anaerobic glycolysis is also known as the lactic acid energy system. Now I'm sure we've all heard of and felt lactic acid before, particularly during high intensity training. So the lactic acid energy system, now keep in mind it never works in isolation. All of these energy systems usually work in combination with each other. It's just the intensity and duration that determines which energy system is contributing the majority of energy for the work. So this one is in the majority when we're doing high intensity exercise of up to 2 minutes. ATP is made by the partial breakdown of glucose and glycogen. Now, glucose and glycogen are simple forms of carbohydrates. Okay, so that's called anaerobic glycolysis. Now, if you break that down, aerobic means using oxygen, so anaerobic, not using oxygen. So this process does not require oxygen. Doesn't mean we're not breathing, just means that the chemical reaction can occur in the absence of oxygen. So the body stores glycogen, for example, in the muscles and the liver, and we often also rely on the blood glucose, so the glucose that's just travelling around in our blood at that point in time. And the byproduct of anaerobic glycolysis, as I mentioned before, is lactic acid. Now, we used to say that that's the waste product, but it can actually be recycled in another energy system, but not at high intensity. So when we are using this system in its majority, lactic acid can be a performance inhibitor. So, primary energy source is stored glycogen and blood glucose. Duration of activity for the lactic acid energy system, about 12 seconds to 3 minutes. Okay, some people say up to 2 minutes, depends on the data that you read. Sporting events, for example, an 800-meter run, lactic acid energy system is certainly what's contributing to the majority of the energy chemical reaction there. 200-meter swim, downhill ski racing, things like that. Advantages, you've got an ability to produce energy under conditions where you don't have enough oxygen. And we'll talk about oxygen debt and deficit down the track, but if you think about it, the amount of oxygen that your muscles require actually leaves you in a bit of oxygen deficit and debt, so that also accounts for you breathing heaps even after you've finished the activity. So you do an 800-meter race, it's not like the moment you finish your breathing rate returns to normal, it's still up for a reason. But one of the advantages here is it doesn't require oxygen for the chemical reaction, but the limiting factors are the lactic acid buildup, because that does really bring some pain and do a few other things to your muscles, and there's a bit of hydrogen ion buildup, which means that your blood starts to become acidic. Okay, so in terms of a pictorial representation, here you've got glycogen and glucose giving the energy for the ADP plus phosphate, so it's contributing to the phosphate, and then the breaking of the extra phosphate there, because remember that's where the high energy is stored, between the second and third phosphates in this molecule here. But unfortunately the byproduct is lactic acid. So that's lactic acid energy system in a nutshell. Go away, have a look at heaps of different sources relating to the same energy system, because there will be some slightly varying information out there. Take notes and prepare for the next video. Thanks guys.